Hello, my name is Jair Rangel. In this video, I'll explain the core functionality of the Interstellar Mission project. We'll focus on the main file, main PY, and also take a look at the files UI and Universo PY, which are fundamental parts of the application. Main file is the entry point of the application. This is where the initial window is defined, the one the user sees when launching the program. Ventana principal, this is a class style inherits from key widget and represents the welcome screen. Visual layout, the window automatically adjusts to 18% of the user screen size. It features an animated galaxy GIF background, giving and the theme visual appealing look. The title Interstellar Mission appears centered in stylized. The main buttons. Go to the Interstellar Mission. When you click it, Air mission method is which open the main mission interface defined in the UI file. The welcome window is closed and the new window is open. Syntax factor. This button is also part of the main window. It lists another module called Patrulla Syntactica, which is present via another teammate. And exit. Exit this closed application completely. UI. A UI file contains the definition of the main interface in the Interstellar Mission. Universal widget. This is the class instanted when the user clicks go to the Interstellar Mission. It defines the logic and graphic interface. User interacts with the simulated universe. It can include buttons, information panels, animation or controls to interact with the universe. Connection to main file. In the function abrir misión interestelar, sus process open the executable the UI file. Universo PY. Universo PY file contains the logic and class that represent the elements of the universe. Classes and functions is where the objects, entities and rules of the simulated universe are defined. For example, it may include class for planets, stars, spaceships, or function to calculate trajectory, designs, or events within the universe. Using tab, UI uses the class UI uses class universe. The class function from universe PY to display information, simulate events, or allow user interact with the universe. The user open the main file. This the menu of application. Button, Mission Interesa, Partitura Sintáctica, and Salir. We close the Mission Interstellar. These buttons cargar JSON, play or start, and reiniciar and restart. This is the legend, origin, destiny, the big star, agujero negro, agujero gusano y zona de recarga. And the events. Start. This is the functionality of the application, and the and the algorithm is the logic of backtracking and resolve the universe. Um, these three files work together to deliver an interactive and educational experience about the university, combining an attractive UI with solid logic. Thanks for watching this video.
Hello, in this video I will explain how our spaceship finds a path in universe full of obstacles, black holes, portals and energy zones. We use an algorithm called recursive backtracking. How the algorithm works, we start at a position in the universe. The spaceship tries to move in four directions: up, down, left, and right. Each time it moves, it loses energy, but I can recharge in special zones. If the move is not possible or the energy is too low, the spaceship goes back and tries a different path. This is called backtracking. Mm, Special conditions. There are special elements in the universe: black holes, portals. Um, Black holes, they block the way, we cannot move there. Portals, they teleport the ship to another place. um, Recursions multiply the energy, can be used up to 3 times. Energy required cells, they need more energy than normal to enter. How we track the path? Every move is saved in a list. This helps us know the full path the spaceship takes. If a move fails, we go back, remove the last move, and try another one. Mm, Goal. The goal is to find a valid path from the start to the end without returning out of energy. If we find the path, we can show it step by step. Um, in conclusion, this algorithm is useful for finding paths with conditions. It is smart because it remembers where it was and avoids bad moments, mobs. Okay. Now, I will explain the ship class, Nave class. This class controls the spaceship, its energy, its moves, and how it reacts to the universe. Main variables. The spaceship has important dates. Um, Energy, current energy, initial energy, save it to restart later. Visit, place already visits. History, saves every move. Recharge use counts how many times each recharge song was used. Um, Log, saves messages about each action. Method can move before moving the spaceship checks. If the move is inside the universe, if it has enough energy for special cells, if a Richardson watt uses less than 3 times, and if it has energy for a normal mode. If something is wrong, it writes a message in the log. Method mob 2. This method mobs the spaceship to a new cell. If it's the first time in this cell, it marks it as a beside. If it's a Richardson, it multiplies the energy. If it's a special cell, it reduces more energy. And if it's normal, it reduces normal energy. Every move is saved in the history and in the log. Method go back. When the ship goes back, this method restores the last energy and removes the mob. If it was a recharge, it reduced the counter. If the cell was only visit once, we unmark it. Okay, logs and reset. The spaceship keeps a log of everything it does, and we can reset it to the original state using the restart method. In conclusion, the ship class is very important because it controls how the spaceship moves, how much energy it has, and what it can do in each cell. Um, Thank you.
Uh, I'm going to explain a little about the syntactic pattern. Okay, let's start with the file to validate license plates. Mhm. What does this code do? I defined a deterministic finite automaton to validate the student's ID in the format in the format gr uh, uppercase letters and code digit. Here we define each state. First, I build the DFI with states and transition to check. Four year digits, one dash, two uppercase letters, another dash, and four code digits. Then the validate matricula function cleans the input. Check format gr range here, and finally use the DFA to validate it. If there's an error, returns the position and the region. Uh, okay, now we are going to talk about the cool validator. First, we import the AFD class and data time to handle dates. Then in the create AFD curve, mm, function, we define the alphabet, state, and transition that the DFA must follow to match the curve format. Next, the validate curve function perform several checks um, that the curve has exactly 18 characters. That the input passes the DFA validation. That the bit date is valid and not in the future. That internal levels don't from offensive words. And finally, that the last digit, the verifier, is correct using the validador dígito verificador function. If all conditions are met, the curve is valid. Um, okay, now I'll briefly explain the AFD class, which models a deterministic find automaton in Python. First, the init method defines the core components, the alphabet, start state, final state, and transition. The main method is validar cadena, which goes symbol by symbol and check that each symbol is in the alphabet, and that a valid transformation exists from the current state. Um, if the final state after processing the string is an accepting state, the string is valid. Other way, it returns the error position and region. The validar archivo method reads a file line by line, validates each string, and collects the results. the the guardar AFD method allow exporting the automaton definition to a JSON file. And finally, cargar AFD reloads a automaton from a JSON file, rebuilding the object. In short, this class lets us build, validate, save, and reload DFA in a very flexible way.